Who would like to start us off? That person's name is Ren. Ren and Jenny.
I'll read.
Alrighty, go ahead, Ajara.
Ren and Jenny are reading the same book. Ren is on page 12 and reads 3 pages every night. Jenny is on page 7 and reads 4 pages every night. After how many nights will they have read the same number of pages? How many pages will that be?
Awesome. Okay, so I put a little hint here because whenever you have a word problem, the first thing you're going to want to do is write your two equations, your system of equations. So would anyone like to start me off just with that part, just with those two equations? And I'll highlight all the numbers that we need.
Next, I think 3 is the x value.
Mm-hmm.
3x plus 12y.
Plus 12. Good. And what's the key word in this example that tells you that the 3 is the slope?
Every night.
Good. Every. Always look for those keywords, anything that's repeating, right? So every night, each night, per day, per hour, all of those are my keywords. And so for my green equation, it's going to be pretty similar. What's that going to be?
7 and 4x plus 7.
Yeah, good. Good job, guys. 4x plus 7. Okay, cool. So now I've got my two equations, and here's where you kind of have to think back to what we did yesterday. What I'm trying to do is find the place where these two equations do what? If it was on a graph, what are we looking for? What's it called?
Can you repeat it?
Sure. So these two equations are basically going to be a line, two lines, right? And what are those two lines going to do if I graph them?
They're gonna cross.
Yeah, they're going to meet up, they're going to cross, they're going to intersect somewhere, right? They're going to cross. So that's what we're looking for. And as a reminder, that's called your solution. And that's going to be x comma y. Okay. So I have two equations. I'm not going to graph it this time. I'm going to use algebra to find the solution. Does anybody remember what the first thing I want to do is going to be?
Plug in an x value.
Plug in, and so what do you mean by that?
Wait.
Because the issue is I don't know what the x value is, right?
Yeah.
I don't know what x is. I don't know what y is. I need to figure it out somehow.
Plug in a 0.
Plug in a 0. Okay, so plugging in zeros is a strategy that we use to find the x-intercept and the y-intercept. But don't get those two things confused. I know that they can kind of sound similar, but let's clear that up right now. So if I have a little graph like this, that's my y, that's my x-axis. And these two lines, this is just a random example. I'm not saying that this is what ours looks like, but in general, if you have a graph like this, there's a place where they meet up, that's the solution, but there's also a y-intercept over here and a y-intercept over here, and sometimes you'll have x-intercepts as well. Now, is the y-intercept the place where they meet? Is that the same thing?
Oh, no.
That's not the same thing, right? So the intercepts, the y-intercept and the x-intercept, that's a different thing from the place where they intersect with a C, okay? So I know that those two words are very similar. I'm gonna make sure that we understand that those are very different things. So plugging in zeros, not gonna help us out this time around. Any other possible strategies? So remember, the place where they meet up is the place where those two equations will be equal. They will, remember that we've talked about this before. We used to call this,
Can we graph it?
so you can graph it, but we're not going to graph it. You could. I could graph it if I wanted to, but I'm trying to focus more on doing things algebraically today. So here's my hint. That point is called the equivalence point. So they're going to be equal at that place. Does that ring a bell at all for what we can possibly do with these two equations? Remember, I want to solve using algebra. What can I possibly do to these two equations?
Oh, okay. Yeah, I see what happened here. We have to do y equals 3x plus 12. I mean, take the 3x plus 12 equal to 4x plus 7. Aw, this is so
That's
embarrassing.
it. That's okay. The more we'll do this, the more intuitive it's going to become for you. Okay. So
Now,
don't.
we added what is this called? A bracket, like an E bracket. I saw what you were going to do.
It all clicked. Exactly. So we're going to take these two equations and make them equal to each other. Because again, remember, the equivalence point is where the two equations will be equal. That's exactly what the definition means. So I can write 3x plus 12 is equal to 4x plus 7. And from there, look at what we have. We have one equation with one variable. We can solve for x. Okay, so go ahead and write this down. And then let's work on solving this together. What can I do to solve for x?
We move the 4x to the left side.
3 minus 4?
-1.
Negative 1x. Good. All right, now what?
Move the 12 under the 7.
Wait, Ms.
Minus
Lopez,
seven.
couldn't we just put like a negative x instead of putting the 1 in front of it, or is that necessary?
You can. That's
You
also
can.
fine. I just like to put it sometimes because it just as a reminder that it's there. All right, what's 7 minus 12?
5.
5.
Negative 5.
Negative 5, yeah.
Oh.
Because you start with 7, you take away 12, you took more than you had, so you end up negative. And now this is why I kept the negative 1, just to show what should I do in that last step.
We have to multiply it by 1?
Not multiply.
Oh, that's with like the
Divide.
sign, right?
Yeah, we divide by negative 1 because the sign is going to flip. So our final answer is positive 5.
But you do multiply by 1 with like the greater than and less than signs, right? Or am I being confused?
With greater than and less than signs, remember the rule is that if you divide by a negative number, the sign flips. But that's not what we're dealing with in this case. So that's going to come later. Okay, we got our answer for x. What do I do now?
Plug it in.
Plug in that x in the original equation.
Good.
Yeah.
Does it matter which one?
No.
No.
Does not matter. Let's do it into A. Equation A. Y equals 3 times 5 plus 12. 3 times 5 is
15.
15. And what's 15 plus 12?
27.
27.
27. Very good. And so there are our two values. So that x comma y
7.
would be 5 comma 27. Yeah.
No, Liz, it's 37.
37? Oh, yeah, you're right. Sorry. Wait, is it 37? 5, 12? No, it's 27.
Wait. Oh, yeah. Wait.
It is because if you add 1 plus 1,
It is.
Okay, 27. I know it's early. Okay. 5 comma 27. Now, what do those numbers actually mean? 5 what?
Ninths.
5 ninths?
5 nights
And
and
20.
I put that in the chat.
and 27 pages. Yeah, you did put that in the chat. I didn't answer you because I wanted to make sure we understood how to get to that point. But yes.
But I did mine the easy way.
What was your easy way?
I just kept adding up every night.
Oh, you like multiplied it by like a
Yeah.
Yeah, so you kind of checked to see when they would, if you started with equation number A, you figured out the pattern.
I started
then-
with 15 in it and 11 in it.
So the way that you did it is not wrong. Like if you want to do it that way, let me explain what was going on. So we know that it's 3x plus 12, right? So on the first night, that would be 12 plus 3 is 15. That's the first night. On the second night, they add 3 more, right? So 17. No, 18.
18.
Then 3 more is 21, 24,
Four.
and so on. And then for equation B, you find out the pattern as well until you get to the same value, which is 27. So that is not the wrong way to do it. It's just, in this example, it didn't take too long. But you can have an example where you would be writing that out for like 10 years because it would be it might not be the 5th night, it could have been the 100th night. And you would have had to keep going with the pattern 100 times. So even though it works, it's not always going to be easier that way. And it's important that we know how to do it the algebraic way because a lot of times that's actually faster. Does that make sense?
Mm-hmm.
Okay. All right, so that is how we complete this type of problem. I'm going to give you guys one of these every day just so that we continue to remember how to do it. But this is actually kind of easier than substitution, so I don't want to spend too much time on it because substitution is a little bit harder and it's worth spending more time on that. So that's what we're going to do today. We're going to continue with substitution. What we're going to do is I have these 5 examples that we're going to do together. And after we do these 5 examples, I'm going to give you guys a chance to work on some problems completely independently at the end of class. I'll play some music and then you guys can work on your own and check your answers with me as you go. So that is the plan for today. And what we're also going to do is see what happens. If you guys remember from yesterday's class, we had one problem where the answer was no solution. And so today we're going to look at what that looks like when you might have one solution, infinite solutions, or no solution. And we're going to look at examples for each possibility.
What of these equations have no solution?
So some of these will have no solution, some of those will have one solution, some of them will have infinite solutions. All right, so we're going to go one by one. You do not need to copy them all down right now. So I'm just going to begin with example A. But go ahead and copy down example A. I have the steps over here on the right-hand side, which you should already have in your notebook from yesterday. But if you didn't write them yesterday, write them in the corner of your notebook as we go through class today. All right, so something I did with my period 7 yesterday was instead of labeling them as equation 1 and equation 2, I started to label them equation A and B, just because it's so I don't confuse letters and numbers. So I've got 2 equations. Which of these equations will it be easier to solve for a variable, to get a variable isolated?
A.
A is easier, right? Now, does it matter if I choose the X or the Y?
No.
No.
No, it's pretty much the same level of difficulty for both of those. So you guys tell me, what would you prefer to isolate, the X or the Y?
Y.
The Y sounds good to me. Let me just reply to someone in the chat. Okay. All right, so let's go ahead and isolate our Y variable. And for some reason, my Apple Pencil decided to stop working. We love when that happens. I don't know what to do about that. Hold on, guys. Sometimes technology really doesn't want to be my friend.
Maybe you need to charge it?
I charged it overnight, so I don't think that's the issue. Sometimes what happens is it kind of like glitches for a moment and you just have to,
Yeah, it lags. It happens.
And you spent so much money on it.
I know, right? It's like, why do I do this to myself? Okay, I think I have to unplug my, I have to like plug it in for a second, but that means I have to unplug my iPad, so it's gonna disconnect. So give me 1 second, guys. I will figure this all out. Okay. Oh yeah, the battery was definitely low. Okay. So I'm gonna have to figure, okay. I have to go get another charger. Give me 1 minute, I will be right back. So I thought I had it plugged in overnight, but for some reason it didn't charge at all. So now it's like at 1%. So this might be a little bit of a struggle today, but we're gonna just figure it out as we go.
It wouldn't work if you like did it with your finger.
No, because the settings that I have on the iPad are like on this app specifically only works if I have the Apple Pencil, and I couldn't figure out how to change it. If someone has any ideas, let me know. But what I'm gonna do is I'm gonna keep it plugged in while I'm not using it, so I'll only use it when it has charged up a little bit. Okay. Anyways, we are going. What did we say? We're gonna isolate the y, right?
Mm-hmm.
Okay.
Yeah.
So let's go ahead and do that. So I have equation A.
Are you on it?
Oh, see, now it doesn't want to work again, even though it was working 2 seconds ago.
Technology is not on our side today.
There we go. Okay. All right. So x plus y equals 5. What do I do to get y all by itself?
You have to subtract
Like
x.
the X.
Good. We're going to subtract the x from both sides. So I have y equals 5 minus x. That's it. And we're done with that. We're done with step 1. Now that I have my isolated variable, what should I do next?
You have to
Plug it in.
get a slope intercept for b.
Wait, no.
So we don't need to be in slope intercept for b. That's the beauty of substitution.
Oh, I'm sorry. I'm thinking about something else. We have to
Yeah.
add
Place
the
the
y,
y.
like the
Yeah.
Yeah, I think Allison and Najara are both going to the same. So we got to plug that into equation B. So I take this portion of my equation and I'm going to plug it in into equation B. Now, should I plug it in? Oh, I think they made a little mistake. This is definitely a typo. This should be 6x.
Yeah, that's what I was saying. I was a little confused. That's why I said like we have to find the slope intercept.
Oh, yeah. No. That was definitely a typo. It should just be negative 6x minus 6y. And so, yeah, so we got to plug it in. Should I plug it in for x or should I plug it in for y?
Y.
Y.
Good. We're plugging it in for y because that is the variable that is isolated. So here we go. Step 2. I take equation B and I plug in my expression for y. Cool. Now what?
We distribute.
Good. We're going to distribute. We're going to solve for x using the properties of equality. So I know that I need to distribute first. So I have negative 6x. All right. Negative 6 times positive 5.
Negative 35.
Negative, think again, 6 times 5.
30.
Negative 30. And then negative 6 times negative x,
Positive 6x.
positive 6x. Okay, what should I do now?
Combine like terms.
Combine like terms. So negative 6 plus
Negative 12?
6.
Negative 12 or positive 12?
What do you guys think?
Oh, 0, 0, 0, 0.
Oh, why is it 0?
Because we're adding negative 6x plus 6, and then if you add that, it'll go back to 0 to the begin, like to the origin.
Right. So we have a negative and a positive. Basically, they cancel each other out. This ends up as 0. 0 minus 30 equals 30. Well, 0 minus 30 is what?
Negative.
Negative 30.
Negative 30. Does negative 30 equal 30?
No.
No.
No, it does not. What does that mean about my?
No solution.
Good, this is no solution. So something that's kind of nice is that when you have no solution and infinite solutions, it's actually a much quicker problem, because can I even do step 3 at this point?
No.
No, you can't. You're done at this point. You don't even have to do step 3. So it's actually a little bit faster whenever there's no solution, because as soon as you get to this step where you have two numbers that are not equal to each other, you can already say this is no solution and you're done. How do we feel about that? Any questions?
Non-taken.
No? All right. So we already have an example of no solution. Let's see what happens with the next one. All right, a little bit different numbers, but there is something that's kind of similar. We still have x plus y. So what that means is that we can solve for x or we can solve for y. How about we change it up this time and we solve for x instead?
Solve for x this time.
Okay, let's do it. So step 1, I have x plus y equals 7, equation A. And this time, if I'm solving for x, what should I do to both sides?
Subtract by y.
Subtract by y, good. So my y's cancel out, and I'm left with x equals 7 minus y. Okay. Should I plug that in for x or should I plug that in for y?
X.
Good. Now we're plugging it in for x because we solved for x. That's what's alone. So here we go. We go ahead and I plug that in to where the x is. So here we go. This is 5x plus 2y equals 23. I'm plugging that in for x. And guys, the more and more we do this, the more and more you're going to see it's the same exact strategy every time, just with different numbers. Okay. Now what?
Distribution.
Good. Okay. So I'm going to distribute. 5 times 7 is?
35.
35. There we go. There's 35. And then 5 times negative y.
Y.
Negative 5y.
Mhm.
I thought that was just 7 minus y.
So we have to multiply the y. It could not be 7. 35 minus, let me see. 35 minus y.
Right, that 5, that's what distribution means. Distribution means you multiply the 5 to everything that's inside of the parentheses. So it goes to the 7 and it goes to the y as well. Okay, that's exactly what that means. Okay, now I've distributed. Now I do what?
Combine like terms.
Combine like terms.
5y and
5y, negative 5y plus 2y.
7y.
So be careful there because it's negative 5 plus 2.
Oh god.
Negative 3.
Negative 3.
Oh, okay. I thought
Yeah.
it was. Wait.
That's why we have to be very careful with those positives and those negatives. And just as a reminder, this is negative 5 because when you read an equation, the numbers take whatever sign is in front of them. So that 5 had a minus sign in front of it, so that we think about it as negative 5. Even though it's a minus sign, it's kind of both at the same time. It's minus, but it's also negative. So it's negative 5 plus 2y. Okay. Next step, we're almost there.
We moved the negative
35
35.
and 20. No.
Good. So we subtract 35. And here's where, again, we got to do a little bit of, make sure we're understanding with the negatives. It's 23 minus 35. So is that going to end up being positive or negative? Think about that first.
Negative.
Yeah, that's definitely going to be negative because we started at 23, but we're taking away 35. And what is it going to be? Negative what?
Negative. Wait. Negative 12.
Negative 12. What do you guys think?
It's wrong.
Negative 12.
Negative 12. I want to make sure that I want to give everyone a
I
chance
feel
to
like
try it.
I'm not right.
Yeah, it's negative 12.
Negative 12. Okay, so how did you guys do that in your heads when you actually do it?
I just added 7 and 5,
Mm-hmm.
and I got 35. So.
Good. So there's a lot of different ways to do it. One way that I do it personally, you guys are right, by the way, is to switch up the numbers.
That's what I did.
Yeah, switch them up because 35 minus 23 is a little easier to do. When you actually do it, you do get 12. But then you know it's going to be negative, so we add that negative symbol.
Yeah,
That's like a quick way to do it. Okay, and now I divide by negative 3. What's my final answer?
4.
4. Positive 4. Negative divided by a negative is always going to be a positive. All right. Step 3 is our easy step. We're almost there. Let's plug that back in. Should I plug it back into A or into B?
It don't matter.
Does not matter, but which one's easier?
I mean B. I'm sorry.
B is easier?
Wait. Huh? Oh, wait. I don't.
Which equation is a little simpler is what I'm asking.
Oh, I mean, A.
Yeah, A is a little bit easier than B just because the numbers are smaller. You know, you always want to pick the one that's going to be less complicated. So just for that reason, I'm picking equation A and I'm going to plug in 4 for Y. It will work if you plug it into B. It does not matter which one you choose, but it is better to choose whichever one's a little bit simpler.
Then it's 11.
Careful, it's
Right.
not 11 because we're going to subtract. We're going to take away 4 from both sides.
3.
So it's the opposite way. Yeah, 3. And there's our answer. Solution is
3, 4.
3, 4. So this is an example where it's one solution because that's our answer. One solution. How do we feel about this one? This one is we had to do all 3 steps. Okay, so
Wait, if you change the x to a 3 and then you add it to 4, it's actually 7.
right, which is exactly what that means. So remember that whatever we got for x is what should work if you were to plug it back in. If you were to plug that x back in, you should get 7 because that's what we were trying to figure out. Okay. Questions? How do we feel about every step of the process? Make sure I have a lot of students who are kind of silent today. I want to make sure that we're understanding. So give me a little thumbs up if you feel good. Or how about this? Because I'm not expecting everyone to feel 100% right now. So give me a thumbs up if you feel better than you did yesterday. And give me a thumbs down if you're still really lost and would like some extra help.
There's no thumbs down button for the reaction. So instead
Oh, really?
of down, we could put like a clapping emoji.
Okay, give me a clapping emoji if that's
No.
the case.
There's like a no.
Did they change the emojis? Because I thought that they used to have both.
They did.
Yeah.
The up.
No, there was like a section in the participants where you could say.
Yeah.
Yeah,
no.
there was like a thumbs down button the participants, but they removed it for some reason.
Oh, yeah.
No, it went back to the place that you could put the emojis, but now it just says yes, no, slower, faster.
Okay, so before we do everything independently, a question, please.
Mhm.
If there's like two slope intercepts, we do the thing where we get the equation and we put it like side by side.
Mhm.
And if it's like this with standard, we have to break it down, and that's it.
Yeah. So that's a very good point. Yes. So if it looks like this, like our bell ringer, where both of them are in slope intercept form, y equals mx plus b, it's easier because all you really have to do is make them equal to each other, solve for x, plug that x back in, solve for y. It's kind of only 2 steps.
Wait, may I take a picture of this?
Sure, go for it.
Okay, thank you.
And then, like we've been doing in these couple of examples, if they're both in standard form, that's where you have to go through that 3-step process of substitution, which in this example we were able to do all 3 steps. All right, we are going to do 3 more examples, so 3 more chances to understand it fully before I ask you guys to try it on your own. Alrighty, here we go. Step 1, there is only one correct answer for, well, I'm not going to say correct, but there's one equation that's definitely going to be easier to solve for than the other. Which one is it? A. Which variable?
Why?
Y.
Yeah. And why is that? Why do I want to solve for y?
It doesn't have
3x
a
is
number
already-
like
yeah.
in front.
Yeah. It doesn't have a
You
number,
could put a 1 in front of it,
but you don't. Yeah. So basically that number in front, remember that's called a coefficient. So y doesn't have a coefficient, which already makes it almost by itself. It's going to be a little bit easier to get it alone. So I've got 3x plus y equals 5. What do I do to get y by itself?
Subtract 3x.
Subtract, take away that 3x. Take it away. Y is all alone. And I'm left with 5 minus 3x. No, careful, we're not combining those 2 terms because they're not like terms. 5 is all alone, 3x is all alone because they would have to both have an x next to them. Since 5 doesn't have an x, you can't combine them. So that's why I keep them separate. That's why I just wrote 5 minus 3x, and you just keep it like that. And so that's very important to keep that in mind. Is this going in for x or for y?
Why?
For y.
For y. We write down equation B, and we plug it in wherever the y is. All right. This is all very similar now. What goes next?
Distribution.
Distribution. And remember, just like we did before, the 2 gets multiplied to both of those values.
So 10
Mhm.
and 6x.
Good. Okay. Now what?
The
Well,
two
that 6x could
sixes cross out.
put us like
The 2 6s cross out because what are we doing? 6 minus 6
is 0
is 0. So 0 plus 10 equals 12. That means 10
plus 12.
equals 12?
No.
No, it does not. This is no solution once more. Now, can somebody remind me, on a graph, what does no solution actually mean about those 2 lines?
Not crossing.
They're not crossing, so what is their relationship to each other?
They're parallel.
Parallel lines. Good job. Parallel lines. All right. Awesome. Any questions? We're kind of getting the hang of this. So if you haven't asked a question and you're still a little lost, make sure you ask as soon as possible before you have to do this completely by yourself. Is there any part of this that you don't know how I got a number, where it came from, what I did to get it? Cool. All right. 2 more examples. Moving right along. Okay, in this one, which equation is going to be easier to solve for?
B.
Yeah, ooh, we're actually going to solve for B now. That's rare. So here we go. We start off with B. Which variable is going to be alone?
X.
X.
The X. X is all alone already. It's a little bit easier. So what do I do to get it alone?
We need to
Subtract
15
7y.
minus 7y.
Good. Subtract that 7y. Nice job, everyone who said that. Minus 7y.
But then it's x equals 15 minus 7y.
Yeah, very close. There's a negative in front of that 15, so keep that negative there. Negative 15 minus 7y. Cool. So far, so good?
Then you plug it in for a.
Yeah, and now I'm plugging this back in to the other equation. So don't forget, you always, if you started with equation A, you go and plug it into equation B. If you started with equation B, you go and plug it into equation A. So we're switching to the other equation. And this is going in for X or for Y?
X.
For x.
For X, good.
You have to distribute.
We'll have to distribute, exactly. All right. So I'm distributing that 2 to both of those values. What's 2
30,
times
the
negative
positive
15?
30.
2
Positive
times
30.
negative 15.
Negative 30?
Negative 30.
Negative 30. Because it's a positive times a negative. It becomes negative. What about 2 times negative 7?
Negative 14.
Negative 14. Good.
14y.
14y. Okay, lots of negatives. Let's be very careful. When I combine like terms, what am I actually adding? Who can tell me?
Negative
14 plus
14
5.
and 5.
Good. Negative 14 plus 5.
5y.
It will
What is
give us
that?
negative.
Negative 9.
Good. Okay, next.
We have to add 30.
Very
Negative
good.
And 12, yeah.
would be
Good. We're adding 30 because it was negative to begin
42.
with. Careful. Negative 12
negative.
plus 30.
Negative 4. Wait.
Take your time with it.
28.
16.
Like 16.
16,
Wait,
28,
18.
18,
18, yeah, 18.
18. There it is. Good. 18. Final step,
Division.
division. We divide by what?
-9.
-9.
Good. So what's positive 18 divided by -9?
-2.
Very good. -2. Nice job, guys. This one was a little trickier because of all those negatives. There was a lot to keep track of. So remember, like, when you're working on this on your own, don't rush through those steps. If you're adding and subtracting negative numbers, that's where you have to take the most time to make sure you have it right. Because if you get that one wrong, if I got y wrong and I plugged the wrong number in, I would have the wrong x. So your whole entire problem would be wrong just from one little mistake. So we have to be very, very careful with that.
Miss, how about if you solve the first one before you solve the second one?
What if you saw?
Can we plug in y to b?
Okay, hold on, Allison, 1 second. Let me answer that question. So if you decided to solve for a instead, is that what you mean?
Yes.
In this example, we didn't want to do that because always look at what the variables have in front of them. This x has a 2 in front of it. This y has a 5 in front of it. This other y has a 7 in front of it. So those are bad options for us. Like, they're going to be harder to solve for. So you always want to solve for whichever variable is already alone. That's why we chose to solve for x in equation B.
Okay.
Good question. Okay, now Allison, can you repeat what you were saying before?
Can we plug in y for b?
Good, yeah, let's plug it into equation B. Again, it doesn't matter which one, but it's helpful to pick the more simple looking equation. So I'm plugging in a -2 for y. What's 7 times -2?
-14.
-14. What do I do to both sides?
And then subtract 14 from 15.
Add 14.
Add 14, yeah. You want to do the opposite of what you see. Okay, -15 plus 14.
Is it a -14?
-1.
That would be -1.
-1. And it was -14, but since I have to add 14 in order to get rid of it, now I'm adding. That's why it's now positive 14.
The opposite of subtraction.
Exactly. All right, there's our answer. One solution at -1, -2. And let's not forget, what is happening at -1, -2? Why do we care? What's happening there?
The equivalence point.
It's the equivalence point. What are those two lines doing?
The crossing?
Crossing there. Good, they are intersecting. Exactly. Nice job, guys. You guys are really, really getting it now. So I'm hopeful that by the end of today's class, we're gonna feel really good.
Wait, how are they intersecting?
So remember,
Solution one. Wait, but
So
what about
2019.
solution?
so say that again, Najara?
What happens if we get an infinite solution using algebraically some stuff?
What happens if you what?
What happens if you get an infinite solution but you don't have a graph to make it like visualize it?
Okay, so what happens if you get what infinite solutions? Let's find out. Let's find out. So here's,
this one has an infinite solution?
it might be. It might be. Let's see what happens.
I think it's when we get to step number 2 that at the bottom they're both equal the same.
Yes, Juan, nice job. So basically, you know how for no solution, you get two numbers that are not equal to each other? So here we got 10 equals 12, and here we got -30 equals +30, and that's no solution, right? When you have infinite solutions, you end up with the same number. So we're going to see.
They both equal each other?
Yeah, exactly. So I believe this last example will be infinite solutions, but let's find out.
That's first at A.
Now, here's the thing though, this one is a little bit tricky. Why what is a little different about this one?
They're both in standard.
They have variables in front
Yeah. Is there a good number to try to solve for?
Not really.
Not
Three?
really. These are sort of not good, right? I think we're going to end up with a fraction. So this is what I'm going to be. This is a challenge problem. I'm not giving you one like this to do by yourself, but I do want to make sure that we see one in case it comes up in the future. It shouldn't, but you never know. You know, these things, you know, you always want to be ready for whatever might come at you. Okay. Well, we still have to isolate a variable. So I don't know, to me, there's no great number to solve for, but I don't know, let's pick who would like to tell me which variable to solve for.
We don't want to mess with negatives right now, so let's go with A.
That's a very good way to think about it, yeah. Negatives are never our friends. So let's try equation A. Now, do you guys want to solve for X or do you want to solve for Y?
Y. No.
It doesn't matter.
X.
There's no right answer.
Okay, I just want to solve for Y.
Solve for Y? Does that
Yeah.
everyone feel good about that?
Mm-hmm.
Okay, let's go for it. So we're going to solve for Y. What should I do? Oops, hold on. Okay, what should I do to both sides?
Subtract 3x.
Subtract 3x.
So it's 17 minus 3x.
Mm-hmm. But now Y is not by itself quite yet. There's going to be one more thing I have to do.
Divide by 5.
Divide, exactly. What
Divide.
should I divide by?
5.
Yeah, 5.
Yeah, we're going to have to divide everything by 5. So here's why I'm saying this is going to be a little complicated. We're going to have fractions. There's no way around it. We're going to have fractions no matter what. So let's just go for it. Let's deal with it. What are my fractions going to be? What would I get as my fractions here?
17 over 5.
Mm-hmm.
But we can simplify that, yes or no, right?
Can we? 17 over 5? Is 17 divisible by anything?
No.
It's
Well,
not. It's not. So we kind of have to leave it the way it is.
Can I make it into a decimal?
No, only because like you could leave it as a decimal, but for the purposes of this class, I want to keep things as a fraction just so we can practice fractions. I know you guys don't love them. I don't love them either, but if you don't love something, you got to practice it until you know how to work with it. Because if you stay away from them forever, then that's not going to help you out when you're taking a test, is it? So the more even if you hate it, you got to practice it. Okay, now what?
3 over 5 is going to stay the same as well.
So the 3, yeah, we're going to leave it as 3 over 5.
So now plug it in into B.
Yeah, so now, we've got these crazy fractions. We got to plug this into equation B. Am I plugging it in for X or for Y?
Y.
For Y, good. But I feel like something good might happen here because we're going to have to multiply things by 10. I think
That's easy.
hopefully that means my fractions will kind of cancel out on me. Let's find out. So what's 10 times 17?
170.
170. What's 170 divided by 5?
17? No.
34.
34, nice. 34. What about 10 times 3?
30.
30.
30 divided by 5?
6.
6.
6, good. Now, is that going to be positive 6 or negative 6?
Negative 6.
Negative 6.
Positive 6 because 3 over 5 negative and then negative 10.
Right, we're doing negative
Oh.
10 times negative 3 over 5. So that's a negative times a negative. which is a positive. So take a look. Okay, we had fractions, but they were only in there for like a hot second. We're done with them already. Now what?
Combine the terms.
Combine like terms. -6 plus 6
Cancels
Equals
out.
cancels
Cancels
out.
out.
Yeah, good. We got 0 minus 34 equals -34.
Oh, this is
Oh.
a solution.
Yeah.
infinite.
Yeah.
Negative 34 equals, these are both equal. That is a true statement. This is what happens when you have infinite solutions.
I knew it.
Exactly. Now, can somebody remind me, if I graph these, what will that actually look like?
The intercept.
Just keep going.
They will be on top of each other.
Right, they would be
Yeah.
right smack on top of each other because they're the same exact line. Even though the equations looked different to begin with, they actually are exactly the same line. So those are the 3 examples. If they are 2 different lines, they cross one time, they have one solution. If they're parallel, what does that mean about the 2 lines? What is the same on them?
Their slope.
They have the same slope. If they're parallel, that's no solution. And if they're the same exact line, same slope, same y-intercept, same everything, they're on top of each other, that's infinite solutions. And that's what this looks like when you're actually doing things algebraically.
Miss, I thought I knew it was going to be an infinite solution because of A and B.
Mm-hmm.
The 17 times 2 is 34.
Yeah, so I was actually just going to ask that. What do we notice?
I just thought it was an infinite solution because when did y'all ask me a question and switch to this one?
Yeah, what do we notice between equation A and equation B?
If you times everything by 2, it will equal to each other. I mean,
Yeah.
times A by 2 equals to
Yeah, so not just positive, if you multiply everything by -2, so 3 times -2 is -6, 5 times -2 is -10, 17 times -2 is -34. And that is something that we're going to see a lot more of on Friday, but that is a really good thing to notice already right off the bat, that can already give you a clue as to what is going to happen. All right, any final questions before I let you guys have some time independent work? Going once, going twice. Alrighty, okay. So here we have 6 problems. You don't have to do all 6. Do as many as you can in the next half hour, which is about how much time we have. Let me just label them so that we can all keep track. So it's completely up to you which ones you feel like doing, but your goal should be to do 3. So if you have enough time to do 3, that would be great. If you are able to do all 6, that's even better, but we have a half an hour. And as you guys work on it, if you would like to check your answers with me, I have the answer key next to me so I can check for you and let you know if you're right or wrong. I'll be playing some music. Feel free to listen to your own music if you prefer, or to turn off the music